So now what is H index? H stands for Hirsch index. It is the name of the scientist who proposed this H index for the first time. This is comparatively recent one. In 2005 or so, for the first time, Hirsch proposed that H index can be useful in assessing the author's contribution to a particular field. Actually, H index reflects both the number of publications and the number of citations per publication. Okay, it reflects both the number of publications and the number of citations per publication. Okay, so measure the productivity and impact of the published work of a scientist or a scholar. So this measures the productivity, right, for how long the author is publishing. So that becomes productivity, persistency or persistence, right, and impact of the published work of a scientific research scholar or scientist or a scholar, right. So this index is calculated using a set of a scientist's most cited papers and the number of citations that they have received. I'll show you how to calculate H index. Suppose again, this is author 1. He has published 12 papers. Okay. In the table, the first column indicates the number of publication 1, 2, 3, 4. But how is it arranged? This has been arranged in a descending fashion based on the number of citations. The paper that has received maximum number of citations has been placed at first position, right? The paper that has received next highest number of citations has been placed at second position, and so on. So 12th paper has received only 4 citations and first paper has received 1200 citations. Now this third column, come to third column. Is the citation number equal or greater than the position of the publication? This is the question you are going to ask with each of these papers. For instance, 1200 is greater than 1, the publication number 1, the position is 1, okay? So there is yes. 800 is greater than 2, hence there is yes. 789 is greater than 3, 567 is greater than 4, and so on, till you come to 10th paper. 10th paper has received 12 citations and 12 is greater than 10. So again yes. But once you cross this 10th paper, come to 11th paper. This has been cited only 8 times. And 8 is not equal to or greater than 11. Hope the things are clear. It is very simple, right? So there is no. Okay? So this last row where you have put yes is the H index of this particular author. This is this is the explanation of H index in very simple terms. So what you need to do is arrange the papers authored by a particular author in a descending order based on the citations received, and then ask this question: is the citation number equal or greater than the position of the publication? So citation number means citation count, rather it is not number, it is citation count. So citation count is given in a second column. So till you get to the point where the citation count is not greater than or equal to the position of the paper, then you should stop. So the last row where the number of citations received is equal to or more than the position of the paper, that becomes the H index. So H index, so this is how it is defined. So definitions are always confusing, right? We need not go into the definition, but this is how it is calculated. So definition is H index is the largest number of H such that H publications have at least H citation. Okay, so in this case 10 papers have, or rather each of these 10 papers has received at least 10 citations. This is the meaning of H index. Okay. Now author number 2, again he has published 12 papers. The citations received have been mentioned in column number 2. Now first paper has received 42 citations, second paper 38, and so on. So till you come to number 10, 10th paper has received 10 citations. So 10 is equal to yes, hence there is yes. Once you cross this, 11th paper has received only 8 citations. So 8 is not equal to or greater than 11, right? Hence there is no. Now 10 is the 10 is the H index of this author. Got it? But see, the total number of citations received by this author is only 222. Whereas in the previous author, the total number of citations received is 4,302. And in both cases, H index is 10. Here also H index is 10. So now there is something wrong. This exposes the limitation of H index. Got it? The author who has been cited thousands of times may also have the same H index as that of another author who has received only a moderate number of citations. So H index cannot be used to compare these two authors. Now that is one of the drawbacks of H index. So H index works properly only for comparing scientists working in the same field. That too, it is not so efficient. Okay, H index does not differentiate between books and articles. This is another problem. Disregards the number of authors of a citing paper. Right? In our previous tables, we never mentioned about the total number of authors in each of these papers, and also the position of the authors. We don't know in how many of these publications the authors were either corresponding authors or the first authors. We don't know, right? The authors could be anywhere, right? Their contribution could be minimum, but still the H index could be higher. Okay, and it disregards highly cited publications, as I told you in the case of first author, right? There were too many citations, but he becomes equal in terms of H index to the second author who has been cited very less number of times. So overcome these drawbacks of H index, a new index has come up, that is G index. So what is G index? The G index is calculated based on the distribution of citations received by a given researcher's publications, such that given a set of articles ranked in decreasing order of the number of citations that they received, the G index is the unique largest number such that the top G articles received together at least G squared citations. I'll be explaining this. Always these definitions are difficult to understand. So we won't bother about the definition. We will know how to calculate a G index. Okay, or yes, a G index. So G index looks at overall record. So when I explain the examples, you will understand the difference between H index and G index. So this is where we are going to calculate G index. Again, another author. I have called him author 1, right? He is not the same author, right? He is different one. Now, publication number, again, the same thing has been done. The publications have been arranged in a descending manner based on the number of citations received. So, the paper that has received maximum number of citations has been placed at position number 1, and the one that has received no citations or 0 citations or least citations has been placed at the row number 12th. Okay. Now what you need to do is you insert one more column and calculate the cumulative citations. See, first paper 20, second paper 18. So 18 plus 20 becomes 38. So third paper has been cited 16 times. So this becomes 38 plus 16, 54. Similarly, 54 plus 12, 66. 66 plus 11, 77. 77 plus 10, 87. 87 plus 9, 96. So 96 plus 8, 104, and so on. So the last column is to be prepared where you will be calculating the cumulative citations. Okay. Now what you need to do? Go on asking, right? Go on calculating the squares of each of these numbers. 1 squared means 1, 2 squared means 4, 3 squared 9, 4 squared 16, 5 squared 25, and so on. Okay. You go on counting these. You go on counting these squares and go till the time when the total number of cumulative citations becomes equal or stops becoming equal or more than the square. Okay. For example, see 8th row. What is this 8th row? 8th paper has been cited 8 times, and 8 is equal to 8. Okay. But 9th paper has been cited only 7 times. So 7 is not equal to or greater than 9. So 8 is the H index of this particular author. Okay, I have given it over right side of the slide. But go on calculating this squared thing. So 10 into 10 is 100. So has the 10th paper been cited, or before the 10th paper, under the cumulative citation column, whatever number is there, is it equal to or more than 100? Yes, it is 116. So what is this squared 11 squared? That is 121. So go to 11th paper. So go on reading the cumulative citations. So the cumulative citation just appears before or in front of this 11th paper. Is it equal to or more than 121? No, it is 116. So H index and G index are different. So in this case H index is 8, but G index is 10, because the number of citations received are comparatively more. Hence this author got some advantage of G index. Coming to one more example. Here the number of citations is more, but the number of citations is only for first 4 papers or 5 papers, and after that all the papers have received 0 citations. Okay. First paper 442, second paper 338, third paper 222, fourth paper 121. So similarly you include a column to indicate the cumulative citations. So cumulative citations are 1125, and he has published a total of 12 papers. So 12 squared, how much it becomes? 12 into 12, 144, and 1125 is greater than 144. Hence this author's G index is 12, whereas his H index is only 4. See, now this is how G index compensates for H index, because this author has been cited a very huge number of times, and hence those citation numbers, they contribute to the calculation of G index. Okay, so those authors whose only few papers have been cited by large number of papers, and whose recent papers have not been cited, such authors will get the benefit of high number of citations for those few papers when you calculate G index. So a G index of 20 means that an academic has published at least 20 articles that combined have received at least 400 citations, because 20 into 20, 400. Unlike the H index, these citations could be generated by only a small number of articles. So this is the benefit of G index. Coming to something called characteristic index. So in this case, this assumes that the first author and the last author, they carry maximum weightage, right? Especially in biomedical literature. First author is the one who has done maximum work. Last author is the one who has communicated the article, usually the corresponding author or the supervisor or guide of the student, right? So senior author, he is called or she is called senior author. So first author and the senior author, these are the two authors who are going to be receiving the maximum weightage. Similarly, second author from the beginning and second author from the last. Okay? These two authors come next in the hierarchy. So many of us, we don't know this, right? So the author's position in a given paper also matters. If you have more number of papers as first author or last author, right, you are likely to get a higher characteristic index, because these things are taken into consideration. See, so far the H index or G index, right, did not take into consideration the number of authors in different papers and the position of a given author. But this index calculates or takes into consideration the position of the author in a given paper. So for example, this one, I have taken this table from a published paper. Of course, I have modified it a bit, right? So this author has published, let us say, yes, there are 16 rows. So there are 16 papers. Okay? So he has published 16 papers, and location, in the first column you get location. Location means in the author's list, his position is 6th in first paper. In second paper, his position is 1. In third paper, his location is 3rd. Okay? Out of how many authors? See, in first paper, the number of authors is only 7. And out of 7, the location of this particular author is 6. So what does it mean? He is next to the last author. So he will be given a weightage of 2. So his position will be considered as 2 or second. Though his location is 6th, his position will be considered as second. Hope I am making my point clear. Similarly, the second paper, location is 1 and total authors are 2. So only 2 authors are there. So each of them gains equal importance, 1 and 1. Both of them carry, our position is considered as first. See the third paper. His position is 3rd, location is 3rd, but there are 10 authors. Okay? So his weightage will be considered as 3rd. The position is 3rd. Similarly, for example, 7th author in a paper that has got 10 authors. The 10th row, I am talking about 10th row. There are total 10 authors in that given paper, and this particular author's position is 7. So what will be his actual position? Right? It is not 7th. Rather, 7 is nearer to 10. So 10, 9, 8 and 7. Though he is listed at 7th position, right, location, but his position will be considered as 4. Right? Hope I am making the point clear. Now, similarly, you go on doing this exercise, and what happens? See, there is two more columns. WC stands for the weighted characteristic score, right? So for first position, you get 1 by 1, that is 1. For second position, you get 1 by 2, that is 0.50. For third position, you get 0.33. For fourth position, you get 0.25, because 1 by 4, 1 by 3, 1 by 2 and so on. So 1 by 5 will give you only 0.2, right, scores. So these are the scores, and this is sigma weighted characteristic scores. So this is again cumulative scores, 0.50 plus 1, that is 1.50, 1.50 plus 0.33, that is 1.83 and so on. So the last row, right, contains 9.53, that is the cumulative weighted characteristic score. H index of this person is 15, because 15th paper has received 15 citations. 16th paper has not received 16 or more citations, right? So his H index is only 15. But what about his characteristic index? It is 9.33. So 9.33 is the characteristic index, or sometimes it is also called C index. And this index takes into account the particular position of the author in the list of authors. So the total number of authors, the position of the author, all this is considered while giving this characteristic index score. Okay, so this is used when you want to take into account the position of the author, right, to evaluate what was his actual role. If most of his papers, his or her papers, in most of the papers, if his position is somewhere in the middle, it means his contribution has been always minimum. Okay, so this is the usefulness of C index. Now there is something called I10 index. So number of publications with at least 10 citations, this is called I10 index, right? So not very popular, but sometimes people use it. Okay, so now concluding the session, right, these are my concluding remarks and take home message. So there are many more indices and metrics. In this lecture I have only covered very essential and most widely used popular metrics. This is something very important. No metric is perfect. There are always some flip side for any metric that you name. Okay, then true impact of a work cannot always be measured in numbers. For example, if you write some policy paper and government accepts that policy paper and immediately implements that policy, and that policy implementation drives huge reforms in a given sector, can this impact be measured in numbers? No. So Scientometrics can measure only certain things, right? But the actual impact cannot be measured by most of these indices. But somehow these indices are being used nowadays to evaluate the journal, to evaluate the performance of a teacher or academician or researcher, and so on, or even sometimes institution, right? H-index of your institution, H-index of your journal. So many things have come up, right? So we should be aware of these different journal metrics or author metrics so that we understand them properly and we will be able to apply them appropriately considering the context of application and use them judiciously. Otherwise, injudicious use of these metrics might lead to disasters. So with this, I conclude this lecture. Thank you for your patient listening.